All right, good afternoon. Hope everybody's having a good day. I don't see anyone in the chat yet, but I'm going to share that we are started around on social media. If you come in the chat while I'm doing this, please say hi. Let me know you're here. In the meantime, I'm going to get everything set up and we will get started pretty soon. I suspect this time will probably not be as active as we've had in the past. I didn't give as much advance notice, so usually try to give more than an hour. But I stayed up, or rather, I didn't stay up. I got up early to watch the World Cup final for the women between Spain and England, and then I went back to bed. So it was at 5 a.m. And didn't get much sleep before that. So, and since there's nobody watching right now, you all will probably see this on the replay. All right. One more moment. Get all my socials updated. Okay. And we can close that out. Okay, well, I don't suspect that we'll have many people today, like I mentioned, but we'll go ahead and get started. And if you filter in, please do say hi, and we'll get going on our HTTP client. So let me switch the scenes here. And looks like I need to fix that. Give me a moment. Because it's not displaying anything. There we go. Okay, you should be able to see it now. Okay, so where we left it last time, we had added timeout middleware to our HTTP client, but we were getting strange exits, like shutdown exits in the tests. So I think we probably need to figure that out. And then if we're able to figure that out, we'll go ahead and add deadlines. So last time we talked about timeouts and deadlines and their relationship to one another. And I think it would be worth. I don't think that I actually added deadlines to this library when I wrote it the first time, but I think it's valuable enough to have that we should put it in there. and then we can have the opportunity for people to add deadlines to their infrastructure and propagate them if they want that sort of thing. And then if we have enough time, we'll look at adding retry middleware with some defaults. I do recall the first time that we wrote this, that we put this client together, that retries were like the most contentious thing. And the other thing that will be interesting about it, that I'm not sure what we're going to do with yet, but is that they tend to interact somewhat perversely with some of the other techniques. So we have to be really careful about, retries triggering a circuit breaker too quickly, So there's lots of things to think about there. We'll probably try to take some middle of the road position on it, put it in there by default, but try to tune it so that the defaults don't trigger the circuit breaker too quickly. Anyway, let's get into it. Let's see if we can figure out what's going on with these timeout tests, and see if we can fix them. We may need to, I think in a previous session we pulled out recon to try to see what happens when something was happening that we didn't understand. And so let's go ahead and put some effort into fixing these tests and seeing why we're getting these exits that are causing the tests to fail after the test finishes. So I believe it's after the test finishes. We'll probably have to verify that as well. Okay, so if you're unfamiliar, is your first time here or something, please go look at the repository seancribb/hardhat on GitHub. This is what we are making. We're making a batteries included. In terms of resilience techniques, liveness techniques, we're including the batteries for an HTTP client that you could use in a microservices architecture or in an app that has a lot of interactions with external software as a service APIs. So if you're building an app that requires subscriptions, so you need to interact with something like Stripe, and maybe you send SMSs, hi Sam, welcome, and so you talk to Twilio or one of the other text providers. This is the sort of thing where like a lot of modern apps are composed of lots of third-party APIs that you have to interact with, and they may not be reliable. As well as if you're building a product or a service of any sizable complexity, you probably have other applications inside your organization you need to talk to. So this is the use case for our Hardhat client, and we'll get started. So let's figure out what's going on with those tests. And here's where we were last time, roughly. And if this is too big or too small, let me know. I have it. It looks really big for me. So if I can manage to get it a little bit smaller, that would be great. But I'm willing to deal with it this time. So let's just see where we were last time and run mixed test. And so we had skipped those tests that failed, right? So let's go and let's remove the skips. Let's remove it from this first one. So this test was, it returns a timeout error after the specified period. So we said that in our test client up here, we defined the timeout to be 100 milliseconds. So any request that takes longer than 100 milliseconds is probably going to be a problem. So what we would expect here is, so we set up bypass, which is our fake HTTP server for our testing, for our test suite, and we're saying we're expecting a request, and when we get that request, we sleep for a second, which is like way longer than 100 milliseconds, and then we respond with 200 hello world. Okay, so we had trap exit true in here. I think this is based on the Tesla middleware timeout. And we may need to reevaluate that, whether that's necessary. So we spawn link a new process, which should get an error timeout as the result of this test client get. Okay, so we're making the basic request to our bypass server, and we should get error timeout. And then we should also receive the exit from this process, and it should exit normal, right? So what we're expecting here is that this assertion error will not fail. That this process will exit normally, and it'll be this PID, and we're saying 200 milliseconds. Maybe we can bump that up. I don't think that's the problem, because I think it's happening elsewhere. But this the trap exit lets us make sure that when we link this process and it exits, it does not crash our test process. Okay. And then instead of crashing, taking down our test process, it'll send an exit message. Okay, so let's run that test. Timeout. Okay, so this is the test that we were just trying. So returns timeout error after the specified period. And we just get this exit shutdown, and unfortunately the coloring of my shell there is kind of janky. So we know it's that test, but we're not seeing what is causing this exit. Yep. Let's go down here and let's put recon back in to our dependencies. Okay, and it already had it in there because I didn't force it to clean up. Okay, and we can close out some of these things from last time. Okay, the timeout test. So let's put in here, I'm trying to think of what, because this is going to be challenging because the process is, like, an exit is a signal. It's not straightforward to trace it. But I think we can probably put some recon trace up in here. I mean, we could maybe do calls. I'm not sure. Let's look at the recon docs real quick. And I shrank that. Okay. And we have hex docs here in the sidebar. Okay, let's look at recon. Okay, we'll jump it down here to each module in the API. Okay, so we look at the API reference. Let's look at recon trace. So we can look at calls here. Modules, any item. So we could see maybe if it's Erlang exit is what's being called. That's probably going to be really spammy, but let's try that. Recon trace, calls, Erlang exit, and we'll give it the underscore for any arity. I think that's right. Right. And then, okay, so yeah, let's print at most 100. Okay. honestly, let's put return trace here. If I'm understanding this correctly, so it's saying these are a bunch of examples, but so if we want to show the result of a given function call, actually we don't want the result of exit. There is no result. I was going to say it would be nice to have the stack trace at that point. But maybe hi Mitch, welcome to the stream. Right, okay. So we could say new processes as an option. New. Right, so all new or existing or a process descriptor. An atom representing a name. Right, okay, let's try this and see what prints out. Because I really think that we're gonna get probably nothing. Okay, so that is interesting. So we get an exit with timeout, and right, okay. So that's on the task await. So we are seeing that, it's trying to await 100 milliseconds. We are seeing that it's getting a timeout there. So that comes from the Tesla middleware, which we'll just open it up here if we have it. Oh, here's our middleware. Okay. So we are getting exit timeout, right? Okay, so if we do task await, okay, so that's coming from task await, which I think we looked at last time, is just after the timeout, it's exiting. So that's interesting. The thing is, I don't know that this is the process that's getting the exit shutdown here. Okay, so here, process 450. Okay, so this might be the task that's getting the shutdown message. It's getting a kill as well. What's curious to me is okay, the other thing here, let's take a different look at this. What if I removed this sleep? We should get this assertion failing and this assertion failing, right? Because it's going to respond like really quickly. So if we, because what I'm guessing might be the case is that the request process inside bypass is the one triggering that exit. If that's the case, then what we can do is maybe look at tweaking how bypass handles its how it handles its child processes, and see if we can work around that. So let's change that so it doesn't sleep, and see what happens in terms of the calls to exit. Okay, so interesting. Um, all right, so this process raised an exception. It got right. It was expecting error timeout. It got that. So that failure is fine. Um, and instead of exit normal, we got the assertion error. So I think what this is telling me, um, and we'll find the recon output here in a moment. Right. So this test failed. We're expecting exit normal. We got a span. So like this was just, hey, we didn't. This was a message we didn't expect. Interestingly, there's no printout from recon. So nothing's explicitly calling exit. This is just an assertion error. This is like raise. Okay, so I don't know that that told us anything. So let's put a sleep in that's a little bit smaller. Um, I don't want to get into race conditions in our test because then we're just asking for trouble. But let's put in a smaller sleep and maybe, um, yeah, it's still getting the exit shut down. Okay, so I think let's go ahead and take that detour into how bypass handles its connection processes, um, and maybe and how it starts up in general. Because like bypass open, this is not like start supervised, right? Um, yeah, let's look at it. I think that that would be worth learning what's going on, so we can start to build up a concept of why we're getting this untraceable exit. Okay, so bypass yada yada. Okay, so you call open. It calls start instance, which is dynamic supervisor. So it starts a supervisor, um, called bypass supervisor, and has bypass instance child spec. Um, okay. Let's look at this. Oh, interesting. Okay, so it actually calls xunit internally. So it callbacks on exit. Verifying expectations. Okay. Hey, welcome, Amos. Thank you for coming to heckle me. Um, let's see. Interesting. I wonder. I wonder if this is it. Format exit any. All right, let's see what the code is. Yeah. Okay. So if you pass shutdown here, it's gonna go format exit shutdown. Okay. And the joiner is that. The reason. Okay. So it's checking multiple shutdown conditions. Here, go wait. And it's probably this. Yeah, so it's probably just saying shutdown. So maybe what we should trace is this. Let's start with that, um, and go back to our test. So we're going to say bypass and this, and see if that gets called. And we restored that. So our test should go do what it's been doing just fine. Okay, I'm not seeing any recon output here. Okay. Yeah, thanks, Amos. How can I heckle a man who uses recon trace? You the man. Well, I use recon trace because I'm not smart enough to trace it in my head. So there you go. And actually, I should remove pid from there because this might be called. We started bypass in the setup, right? So it might be called from the parent context. So let's remove that restriction on it and see if we get any output. And Chris, thank you for joining. You know, quick detour, Chris, since you're here. I think it would be awesome later down the line if we get Filibuster as a plugin for this. So we should talk. Okay. Yeah, we're still not getting any output that's useful from that. Okay. So I would like to get rid of this trap exit, and I think that we're going to do ref pid. Let's do spawn monitor instead. I really dislike spawn link in tests. And then let's look at real quick that message pattern. Spawn monitor. It's PID reference, and then we're gonna have to look at monitor to see what the message format is. I always forget this. I have to look it up. Okay, so it's down, ref, process, and then, yeah. So and let's switch these. Okay. And let's match ref and pid, and then we don't care about the reason. Hi, Rich Carlson, long time no see. Welcome to me bumbling around with with recon and timeouts. Testing timeouts, probably the worst thing to try to test. Okay, so what did we change? So with this change to a monitor, we're just asserting receive on down, then we don't have to trap exit in our test. And maybe we'll get something else because we're not trapping exits. That's my theory, at least. Okay, so you know that still passes, so to speak, but we're getting this exit shut down. All right, let's go back to looking at bypass. Okay, so the magic of bypass happens in this dynamic supervisor. Let's go to the instance with a gen server. Okay, so it opens a socket with ranch. Okay, a lot of stuff we don't care about right now. Handle cast, okay. Okay, so this stuff, put expect result. So it's collecting the expectations. I wonder what this debug log. Let's see here. Retain plugs. Okay, so this is where it's setting the expectation. Stub expect or expect once. And just puts it in the state. Okay. Pass. Okay. This is not really telling me. Okay, so on exit. If anyone knows where this stuff is, I haven't really explained what I'm looking for. What I'm looking for is what happens to that individual request process. And I think that we saw over here that it's setting up these callbacks on exit, right? And it's calling this do verify expectations. Right. So it says it sends a gen server call to this bypass instance, which is the on exit message. So over here, where is that on exit message? Okay, so on exit, then it goes, okay, do exit and the result, and then it'll say stop normal. That should not cause an exit. Now this do exit, I'm wondering if it's calling exit on the individual request processes. Okay, so if the socket is gone, the state is unchanged. So do down. Okay, we'll need to look at that. I'm guessing what that is doing is tearing down the socket. Right? Okay, because then it's setting the socket nil in the state. That makes sense. Okay, if the state is passed, then it returns okay. Right, so I'm not seeing anything about it. This retain plugs count. I'm guessing this is like you've got existing requests waiting. Then it takes this message and it takes the caller and it pushes onto this list of callers waiting exit. So that's like the age-old trick of taking a handle call and deferring the reply. And then the next time it gets an on exit, it'll go to this state if these are finished. Okay. So this does. Let's look at retain plugs count. Right, expectations. Okay. New route. Okay, raw socket options, yada yada. Okay, let's look over in bypass plug. I'm guessing this is what gets called when. Right, so we should look back up here and how it initializes the socket. Okay, ranch TCP listen. Right, okay. Give me any port. Do up. Oh, right. So it initially listens on port 0 so that it can get a port number. and then it reopens it, and then it sets plug cowboy HTTP to bypass plug. Okay, so got it. Okay, so it takes this listener and starts up cowboy using this as the entry point. Okay. So yeah, fine. Okay, so call is going to be called by plug cowboy. So it's getting the connection and the PID, which is the state of the server, essentially. Okay, and so then it's trying to get the expect fun. So that's when we call, in our test, we call bypass expect once. This function gets thrown into the bypass instance's state. The plug pulls it out. And then it tries to call it. Interesting. So I wonder if what we're getting here is, and I've suspected this for a while. I wonder what we're getting is the test succeeds, and then this plug, this function doesn't return because it's still sleeping. The process is still sleeping. It gets an exit shutdown signal from bypass because it's shutting down. It's linked here in our setup, right? When we call bypass open, which is not actually true. Let's go up here and look. Oh no. So it calls setup framework integration, which does the callbacks. I'm surprised it doesn't do start supervised. Interesting. Okay. Anyway, I think it's the port. Okay, so here's my theory. My theory is that we're sitting, like when the test finishes, we're sitting here in fun con, right? Which is our expectation. And it's getting an exit shutdown signal from plug cowboy. And so this is exit shutdown. It falls into this clause, catch, exit shutdown. And then we put result, and then we raise, we re-raise that exit. And this, so let's look at bypass instant. It's calling put expect result. I'm sorry, is that a call? No, it's a cast. So that message may not even get there. Let's throw our tracing back in here. I want to see if we get this called. And then maybe we can suss out if it is this particular function. Yep, let's try that. Because I really want to be able to rule out, is it bypass or is it something else? And then maybe there's a way. No, recon trace did not trigger there. Okay, so it's not likely that. Let's trace Erlang raise. YOLO. Honestly, let's just make doubly sure it's not this. Okay, we have no recon output there. Okay, so let me just say, and I know that should be evident at this point, testing timing sensitive things in a concurrent situation is really freaking hard. Oh my gosh. Like so we found um no clues looking through all of bypass really. Like we traced things. I think maybe we should look at maybe we should look at what this debug log does. Okay, so it just, calls logger debug. We could probably set this, right? Let's just set that temporarily, and maybe we can get some config, bypass, and what was that? Where'd that go? Wasn't bypass, is utils. Okay, so enable debug log. And we'll set that to true and see what bypass prints. I think that's at least useful. Yeah, so Chris, good question. And I showed that earlier. It had a black line. That's actually just the name of the test, and it has to do with weirdness with my shell. I don't know why this is printing back in black, but nice AC/DC song reference there. Okay. We don't. Let's. Okay. Close to. All right. Let's go back to our test and try this one more time and see what happens with it. Bypass printing out its stuff. And I have to set the logger level because that was at debug level. Yep. Oops. I didn't mean to hide that. And this is going to be a little bit harder to see. So I think what I'm going to do is skip these other ones. Skip. And then we're not running any of the other tests. And that didn't do what I wanted because they've changed how that works. Logger. I think we can do it at runtime. Configuration, boot, compile, runtime, boot configure, compile time, runtime, level. Okay, so we can call logger configure just in our test. That's probably a better way to do this. I sometimes hate that dash. I can't switch to it directly. Level all. Let's do that. Okay. Logger.configure level all. And then let's run it and see what we get from bypass. Nothing. Love it when a plan comes together. Let's do it up here before we get... the other thing might be the case is our test helper is not doing anything with logger. Okay. Once more with feeling. Oh, not deps, get test, please. Yeah, we're not getting any of that. And I think that was a dead end, unfortunately. Okay. Was this too ambitious? Maybe. um, so we're still, one thing we could do is go into our timeout middleware and, um, just do prints in various places. Like we could do IO put as rescued async, stupid stuff like this, and see if any of it's happening in here. I don't think it is. No, wait. Okay, before we do that, I'm certain it's not this because we already traced and we saw that the timeout is being hit and we're returning error timeout, right? So um, like this is not failing. I, I think I tried this off stream and I don't think that it did anything. But I want to just see. Hello, come on. So we can call down, which closes the socket. Okay, so expect, right? Expect once is what we're doing. We don't actually care in this case how many times it's called. It should be only called once, but oh, I guess we have to change it to that. So let's say get, and we're just going to say slash, and then it gets the con. Okay. Let's try this. I don't think it's going to fix anything. The other possibility is that let's try this. And if this doesn't work, I want to try one more thing, which is plug cowboy. We could trace plug cowboy and see if it's printing out anything interesting. Okay. Okay, that made no difference. So I don't see any reason to change this. Right, there's no reason to change that. And bypass down didn't do anything. Let's run it one more time just to be sure. Yeah, no change. Okay. Honestly, that'd probably be called at the end of the test anyway. Print in the stub and see if it's getting. Yeah, that's a good idea. Okay, let's try that. Bypass called. But okay, Chris. But I think that we would probably get something else in here. Let's just try that. That's a good. Yeah. So it was called. We are getting to that sleep spot. We could try something here and see if we're coming out of the sleep, and I think I'll reduce the sleep time, and see if we get anything. Note it didn't print that. let's make it a bit tighter. Let's make it like 110 milliseconds. And see if we get, that's getting dangerously close to race conditions. So okay, so it's not, it is getting, the exit is happening while we're sleeping. It's never getting to the, now we could sleep for the exact amount and start triggering race conditions, but I didn't print, I removed the print. Awoken, that's probably a better print. We're not seeing that anywhere. Now let's reduce the sleep to 50 milliseconds, and this should fail, and we should get printed awoken, right? Yeah. So it awoke, and then we got the assertion error. Interestingly, that didn't fail the test, and that's okay. So that's good information. I think that's probably why they have trap exit on this, because and why they use spawn link. So I think we need to do that. True. I think we need to do that. Bit normal. Because otherwise this just, like you saw here, where's our last mix? Yeah, so the test did not fail, but we got this, you know, child process printing an exception because of the assertion error. So I think that's reason enough to do this. Okay, so let's put this back to something closer to being able to pass that assertion. And what we were going to do originally, let's put recon trace back in. And I want to see plug.cowboy anything. And let's see 100 calls. And we may need to put this up in the startup. So let's do that here, because then we'll be able to see anything that happens when after we call bypass open, right? Okay. I messed that up. How do I mess that up? Process flag. Yeah, it's process flag, not trap exit. Right? Okay. Did that wrong. Y'all should call me out on that. Okay. Okay, so it calls HTTP plug cowboy HTTP port. Okay. And then nothing. So there's nothing interesting really there in plug cowboy. Bypass.plug. Let's see any of that going on. I feel like we looked enough at that, but okay. More interesting stuff. Okay, so call, here's the request we got. Right, request path, path params, etc. Okay. Scheme, the peer. There's our trace headers. That's fun. User agent mint, right? We might want to override that. That might be fun at some point. Okay, but we're not seeing, going down, so we get this exit shutdown. We're not seeing it unless it's like completely unable to trace that. we're not seeing it do call put result. I'm going to do something evil. Crashed class reason. I don't really like doing this, but we're gonna go in here and dex.compile. Did it recompile bypass? Yes. Okay, we get the call. Okay, my feeling is this is either, this does not trap exits. So and shutdown is a normal type of exit, right? That's a supervisor saying, we're done, you need to shut down. So I don't, let's try one more thing. I'm going to trace dynamic supervisor because this is the thing that is supervising the bypass instance, right? And maybe it's calling, or it's sending the shutdown signal, and then the bypass, not that. The bypass instance, right, is receiving the shutdown signal. One thing that we could also try, just for kicks, is restart transient. One thing we could try in here is having a terminate callback. I don't think that they have one, but that's an optional callback on gen servers. So if we put one in here, we could see if it's the instance receiving the shutdown signal, in which case it should have the opportunity to exit cleanly. Let's see if it has terminate. No, it doesn't. Gen server. Right, so terminate. Let's add that to this also so we can get another piece of information. And I'm not sure where to do that in this file. Well, let's do it at the top so that we can remove it later. Terminate, and what was it? Reason state. We don't care about the state. And let's put us. Actually, let's print the state. We don't actually care. And I think this is like it must return okay, or any term. So reason is normal, shutdown or shutdown on a term or any term. This is just as clean up, right? So it's not guaranteed that it'll be called when gen server exit. However. Okay, so terminate is called if the gen server traps exit and the parent process sends an exit signal, or a callback does one of the following, returns a stop tuple. Okay, exit signal from its parent process's supervisor when the tree is shutting down. Right, this is what I'm kind of expecting at the end of the test, is that that dynamic supervisor is shutting down. I guess, right. So, okay. Yeah, let's see if bypass instance shut down reason and state. Actually, let's inspect state just so we get a pretty print. I don't know that this is going to fix this, but let's see about it. Unity test. Fine, I don't actually care. Okay, next test. Interesting. Okay. So shut down normal. I have a problem here. We're including too many tests. Let's focus that test. Okay, so we're doing multiple things here. We're tracking the shutdown of that bypass instance process, and we're also printing, we're tracing dynamic supervisor calls. So we can see here it's starting an instance under the bypass supervisor, and then that's translating to handle call start child, and it calls child spec. Okay, so this is right. This is us calling start supervised in the setup. So it calls child spec and then it calls start link with the name of the process. Okay, and then let's see, init on dynamic supervisor. Interesting. Okay. All right. Okay, and then we're starting this start link. Okay, so this is starting the supervisor itself of our connection pool. And then here we are getting a connection. So we're starting a child connection to localhost. There's our bypass port. Okay, and then that goes into the handle call. Okay, and then here's our bypass instance shutting down. So no monitors, port, the socket is nil, pass is false. There's no callers awaiting exit. The expectations are any, and here's this function, right? Expected once, request count 1. Results, exit shutdown. This might be it. So our instance is shutting down and its state is exit shutdown. The state of the request, right? This is what happened to the request. It exited. Oh. And I wonder, let's go back up in here because I think this is, let's say, verifying expectations for bypass, right? Thanks, Ricard. Nice to see you. Thanks for coming. I know we're really feels like we're flailing on this, but I feel like we need to get down to the bottom of this so we can write the test correctly. And okay, so let's see if there's any. And I actually want to get rid of that trace for now because we don't actually care. That's not telling us anything new. Okay. Uh, so this looks like to me. Oh, well, I didn't recompile. Let's recompile the depths. That may be the problem. Okay. It's interesting because it looks like um, it's not checking those expectations on exit. And that probably indicates that it's exiting before it can check those expectations, right? Um, what we could do is we could call bypass verify expectations in there in our test and see if anything happens, right? Yeah, well, not available in exit unit. Why do you make it hard? Because you literally just do this. Ugh. This could be factored so differently. Okay. Now we could do bypass instance call on exit and just see what is returned. That would be potentially interesting. We need to extract the PID from that. Okay. Let's try that in our test. Yeah. Okay, so at this point we'll say bypass instance call, and this is bypass.pid, and we'll say on exit. And let's IO inspect that. Now the thing is, no, it won't. It won't. Let's just see what happens there. Oops. Where did I print something that's not printable? Bypass instance terminate. Let's inspect the reason too. It's probably, yeah. Okay, that's probably what it was. Be careful when printing things out to the console, kids. Okay, still not. So bypass instance line 11, which is what we added. All right, so we call. So hey, that's interesting. Okay, so it printed exit shutdown. This is. Aha. Okay, so in the sleep, It's receiving a shutdown signal. And this is getting somehow sent to the instance. Right, this is the thing we added. I actually tried to run that. So I actually want to go back there and remove. I did remove it. That's fun. Honestly, it's strange to me that we were getting this not implemented for no proc gen server stop. And this is hilarious to me because it's literally printing it here. And it's basically saying it's not. There must be some other place where I'm doing IO put s, and so this is in bypass instance terminate 2, right? Which is right here. All right, let's just change this to io.inspect, and we're gonna put module terminate reason state and move on. Yeah, I think I need to recompile. I agree, Chris. I think I need to recompile. But also, that's really weird. Okay, so it did compile bypass again. Let's run that test. I'm still okay. So interesting. Okay. So this is our result of our on exit. And okay, so the reason I get it now. So the reason we're getting this this is no proc, right? Is because when you do on exit in call in the instance, it is exiting after that, right? It's saying stop normal. Now, maybe what we could do is, and I saw this earlier. Let's remove that. Let's say bypass.pass. This sets it to pass. So like, let's not care about those expectations, right? And so even if this has exited, it will ignore the state of those individual requests. And just saying we passed because we say we passed. Trust us. Okay, make sure we don't have any tracing up here. Let's get rid of that for now. Okay, I think that's worth a shot, right? And then because we were kind of getting around what the test framework expects right here. Like we were calling on exit, which is sort of an internal function, and getting this result back. And then it tried to go, hey, call on exit again. And it's like, nope, I'm already done. I'm gone. I've already terminated. So, okay. Let's try just throwing that pass in there. Oh, how about that? No timeout. Okay, so I think we know what we need to do. Just for safety's sake, I'm gonna go ahead and put this in here. We're not gonna skip this, right? And let's go down to this one and say bypass pass, because if we get through all of these assertions, then we should have, all those expectations can be ignored on bypass. Okay, yay! Thank you for sitting through that with me. God, that took 75 minutes. But hey, I learned about the how bypass works. So let's see if we can get all these tests to pass, and then we'll clear out any of the changes we made to bypass and recompile all that goop. Okay, so now our tests pass. Cool. So I'm actually going to make steps.clean bypass. And it's gone. Okay, and then let's steps.get. Deps.compile. Okay, so that's I think that's a lesson for me for the future, that if we expect any request process to linger and then later be terminated, we should, when we get to the end of our assertion, say, yep, it just passed, and we don't care about the assertions of those particular requests. Okay, and let's run all the tests, and we have 0 failures. Okay, so let's look at the status. And I think I want to do some, so we don't need recon in our commit. Let's see, let's look at the diff. Okay, so this is a meaningless change. I think I'll put it back. It doesn't actually matter how long it sleeps as long as it's longer than the timeout. And then we add the bypass pass. Okay. Whew. That was a journey. And yeah, we're just making that consistent with the other test. The other test has the underscore in it. Okay. That looks good. Okay, we're going to say this is fixed timeout test race conditions. They weren't actually race conditions. Failing on exits. Okay. And we'll push. Oh yeah, so I had dependabot merge some changes, so I need to rebase, and then we'll push. Yeah, let's do that, make sure that we're updated. Compile. Okay. Run the test one more time. I don't think xdoc would change that. Okay, now let's push. All right. Okay, so we're going to close that. Don't save. Close that. Don't save. We're not changing any of bypass. And okay, so come on, Emacs, where'd you go? You have my org mode. Okay, so we fixed the timeout tests. Woo! Let's add deadline to our timeout middleware and figure out how to configure it. So I talked about this at the end of the last stream, but I think it's worth talking about a little bit more. Briefly, deadlines are like timeouts, but they're global across your application and hopefully across your infrastructure. So the best, just like timeouts are liveness tool, right? Deadlines are liveness tool at a larger scale. So if you have deadlines, we'd love for that to be automatically propagated into your timeout. And then if you that way you won't be like doing work that will never complete before your caller expects it to be done. Again, we're looking at ways resilience on multiple angles, not just like failures, but also latency and resource consumption concerns, right? So deadline honestly is like a module that just sets some stuff in the process dictionary. um, so we can integrate it, I think, directly into our timeout middleware, um, and maybe we can have it turn on or off. I don't know. But you can see here the thing is, if you want to set a deadline, similar to how we had to propagate the open telemetry um, process state, we also need to propagate the deadline state. So let's go and add that. And we can add some tests here in a minute. Excuse me. Okay, so we're using the OpenTelemetry process propagator so that we don't have to do that ourselves. We're using its alias for the task module. So we just need to add one more thing on there. Um, and I think um, let's think about this. Right. So we need to. I think this is a thing where we should look at. Um, I kind of want it to be transparent, first of all. But we should be able to change this, right? If there's a deadline set, um, we should respect the deadline, even if the timeout is set to something else. Um, and we should also, if there's a deadline set, but the deadline is greater than the timeout specified here, we should use that timeout as the new deadline inside, right? Um, so you can further restrict, like, let's say you need to call 4 services and you have a budget of 400 milliseconds. Maybe you only want to give this one you're calling 75 milliseconds to finish. Um, so you should propagate that deadline to that thing you're calling as well. Um, so okay, so we're probably going to need another option here, which um, could be something like uh, controlling deadline propagation. Um, and then even if we're not propagating deadlines, so that's another thing here, is we would want to um, put something in here that adds a header, which is the deadline, right? Um, okay, so let's just make a little list here in a comment. So we want to be able to control deadline propagation. So whether it's on or off, on or off. And then we want to transfer the deadline state to the task, the spawn task, right? And the other thing is that we want to use the smaller of timeout deadline as the internal deadline, so that you could specify timeout in the options, and that would override the deadline that you're propagating, right? What else? And this is a stretch, I think. we want to adjust the results and OTel events based on whether it was a deadline or not. That, I mean, in some senses, I would love to see error deadline exceeded rather than timeout here. Maybe we can choose for the name of this event. We could also do something like check if the deadline has been exceeded already, because deadline reached, right? We could say we could return early, error deadline exceeded. We Yeah, so there's this deadline time remaining, right? So we could do something like this. That's interesting. So it returns infinity if no deadline has been set. Okay. So yeah, we'll have to figure out what the lesser of these two is. So if it's infinity, then we definitely want to use the configured timeout. Otherwise, we should use the deadline, or the smaller of the two. And that's so that's some interesting. And this get and then set here might not be exactly what we want to do. Because it puts the deadline and the start, and actually probably what we want when we propagate it. Yes, so deadlines are good question. Deadlines are useful because the deadline can span multiple async function calls, whereas a timeout only applies to one call. So first of all, we're not talking about async code really. The deadline is in the current process. This is how much time I have to get stuff done. So that does, when I say it doesn't involve async, like forget async. It's not like async await in any other language. You either are doing the stuff in the current process, or you're sending a message to another process and waiting for a reply. So the deadline is bigger than just a single process. It is for the entirety of a workflow in your app, is the best way to think about it. So let's think about if you had a pretty high traffic website serving the latest news, as well as by the way, that's where this came from. And your front page is really high traffic, right? And if you can't load like the preview of a certain story within a certain amount of time, you would rather not show it, because otherwise your people like hammering the refresh on that page to see if there's something new that came out are gonna be waiting for a long time, and you would rather serve something rather than nothing, right? So this is, I talk about liveness techniques. This is harvest versus yield. We're talking about, do you want to get all the stories, which is like 100% harvest, or do you always want to respond with something, which is 100% yield? This is similar to consistency versus availability. There's a big design space in there that you can pick. Yeah, I want to get at least, say, 10 top stories to show on my live news website, but I don't want to take longer than 300 milliseconds to render the page. So what you would say is, when maybe you've got some front-end JavaScript, for instance, doing single page app stuff, but when you go and you request, give me the top stories, you want to say, I need this within n milliseconds. So what would we say? 300 milliseconds? I don't know. We're just making stuff up. But that can be part of the request from the front end to, I don't know, your GraphQL API or something, or whatever API you're using to serve that page. And then, if to construct those top 20 stories or whatever, it has to make calls to 4 or 5 different services. You have a 250, 300 millisecond budget to do all of those calls. And so then it can go, yeah, hey, I'm making these calls to you. I need you to return in this amount of time so that I can meet my deadline. And then, if you get to the point where you can't get all of the data back, the front end might not be waiting for you anymore. Or, if you've got downstream calls from those top 4 or 5 calls that the API servers is calling, maybe you don't want to wait on those things because you've got to serve that deadline. So deadlines are, they're a way to say, like, timeouts, but across your entire infrastructure, across an entire request flow. So this is something that I would say it's most useful in bigger products and applications than it would be in like one you can run with one server. So if you have microservices, or if you have, like I said, like 3 third-party services, and you have tight budgets on like your SLO to your clients, deadlines will help. Okay, I hope I've motivated that enough. I don't want to spend too much more time on it. I think we should go about integrating this library. And yeah, okay, so we don't use that. Okay, so really this doesn't have very many functions in it. Right, so I think let's you're welcome, Evans. Please, that is partly why I do this stream, not just to write the code, but to also help people learn. So thank you for asking that question. Okay, so let's figure out deadline propagation. So let's make a new. So we have this safe async, which is handling, the task async and like propagating exceptions. And this is just, remember, this is copy pasta plus modification from Tesla's middleware. The main thing that we did last time is we added this open telemetry process propagator. Excuse me. So let's make a new function in here which captures the deadline, and then propagates it into the task. So the interesting thing is, so this function is going to need to do 2 things. It's going to need to juggle the state coming from the outer process and going into the task, but it's also going to need to handle adding a header to the deadline. So the receiver of this call can see, hey, I have a deadline of this. There's a question in my mind about whether that should be an absolute duration, or whether it should be, hey, here's the wall clock time. And I think it's probably most likely that should be a duration, because wall clocks are really hard to synchronize. And then if the user of this middleware acts a little bit pessimistic about their timeouts, then they can give themselves some buffer around making this call to whether they meet their own deadline. So I think that's probably the way we should go. Let's so these are part of a new function. Let's figure out what the smaller of the internal, as the internal deadline, the smaller of the timeout or the deadline is. So I think let's do something like timeout and is deadline. And let's do a case here. And we're going to construct, so we have deadline. Oh, I'm sorry. Before we can do any of this, let's back this out real quick. Okay. We need to add that library to our set of stuff here. So and let's see what it is on hex. Is it on hex? Ooh. Chris Keithley, did you push it to hex? Let's just try. It is 071. And let's see if we can get that. Okay. So we're good. Okay, so let's go back to what I was trying a moment ago. So we want to know whether deadlines are active or not. And we're going to rely on the calling process to have a deadline set. So we're not, one of the things that deadline does not provide is a plug. I actually think would be a good contribution to that. But I don't know that is something that the maintainers want to do yet. So we're going to require that this timeout option should always be there. But here, let's compile the depths first. Okay. So we should be able to. Might have to restart the language server. Anyway, let's look at the back of the module, or we can look at the README. Okay, so we can say time remaining, and if it's not set, that will return infinity, right? Actually, this doesn't need to be a case. Let's do it as an if. So we have if deadline.time remaining if it equals infinity. Right, so that would be the case where it's not set, which we saw in here. Infinity, time remaining. If it's infinity. Okay. Sorry, that's right. So if there is no key in the current process, then it's infinity. And then it's just doing a quick check of whether the deadline has been reached. So that way you don't get a negative timeout. Sorry, I take this back. Let's do case. If it's infinity, then we know we have no deadline. So let's return keyword dot fetch ops timeout, and it's not a deadline. If it's any other value, right, then what we want to do is use the so the deadline is true, right? We're using deadlines, but we want to use the minimum of that value and our timeout. And honestly, let's just put this configured timeout up here because we're going to reuse it. Okay, so now this becomes our timeout, and then we know if we have, so that'll happen. That'll go into this task await, right? So we're never going to exceed the deadline with our configured timeout. Okay. And this is deadline will tell us whether we need to, when we get inside the child process, whether we need to set the deadline. Right? Okay. So I was going to make a separate function, but let's just do it in line here, and then if we don't like it, we can refactor later. Okay. So if we say if is deadline, we're going to deadline.set the timeout. Now, I suppose in this case it doesn't actually matter that much because we know what's farther down the stack. But we could potentially make the deadline propagation be a separate middleware. And then it's automatically propagated inside the timeout, and you put that middleware, the deadline propagation, inside, like at a deeper level than the timeout middleware. And we could do it by default. So if the deadline is set and that way, even if you're not using the timeout, you could still propagate your deadlines. I actually kind of like that idea. And then we can test that deadline propagation separately from the timeouts. Okay. Only thing here that's a little bit potentially problematic is we're not actually using deadline get. We're relying on the fact that we want to set a smaller deadline if the timeout is smaller than the current budget of the outer deadline. So I don't know. I think this is okay, and maybe we'll one-liner this as opposed to having an empty else branch. Like, that's a pretty minimal change for the getting the propagation in there. Okay, so I think let's get this so we transfer the deadline state, use the smaller of the timeout deadline, the internal deadline. We could change this. I think it might be worth looking at the semantic conventions to see if there's anything in here that, because this is an event we're adding. I wonder if there's any like there's any span attributes that we should be adding. So let's take a quick look at the standard. Okay, I think we have what we need here, and we'll use this time remaining again when we do the other middleware. So let's look at that OpenTelemetry standard. OpenTelemetry, the org. No, I don't want to look at that. Let's see. I think it was called semantic conventions. There we go. I don't know why it thinks that's a shell, but so honestly, there is a docs website for this. I will get to your question in a second because that's really detailed. Okay. So general trace. Okay, server address. Care about that. Client attributes. Network attributes. Source and destination attributes. Connection carrier attributes. Remote service. Period. Okay. Identity attributes we don't care about. Thread attributes. Nope. Source code attributes. And but I don't think that this is going to tell us. So okay, thanks Chris. Yeah, like you could get into some really interesting scenarios if you're propagating deadlines everywhere. And the thing is though, like so if you're in your example, process A is monitoring, or rather if the exits propagate upward but A has already exited, it just goes into the ether. There's no destination for that. The thing is, you can achieve that. Like you could do, for example, this deadline has this exit after, which is really pretty cool. And I think I can just go back in my history. Yeah, so this is fun. You can say exit after, and it will create a process which is supervised by something in the deadline app that will send an exit message to the caller when your deadline is reached. So this is how you can enforce it. Example, I mentioned there's no deadline plug, but you could conceive of a plug middleware for your server app that reads the deadline out of the propagation header, and then it says, okay, exit after, set the deadline, and then call exit after, and then this request process will be killed when that deadline is exceeded, and you could potentially respond, but you might not need to. You might just like drop it on the floor. And I think that like it's a pretty brutal way to make sure that you don't exceed the deadline, but that is a case where, if you have this chain of processes that are propagating deadlines, and the request process exits and it's not linked, then the other things that reach their deadline might not be able to send any notification back to the original request process. So thank you for sharing that. Okay. So there's no like open telemetry convention on this. They're really kind of not too heavily specifying what attributes should be in this sort of case. Honestly, we could change module to code.namespace. But it's okay. Yep. Okay, so deadline propagation. You probably be the next step. So let's go into our test now and try to figure out how we should test this. Okay, so let's say uses the smaller. So we talked about what we want to do as far as the functionality. We need to test each of those scenarios. It uses the smaller of the set deadline or the configured timeout. We just say uses the timeout when there's no deadline set, right? Propagates the deadline into the child task. That's probably going to be a little bit harder to test. When we were talking about OpenTelemetry propagation, we did that by checking for the trace parent header, right? No, we didn't actually check propagation, did we? But that wasn't part, right? We were just using the OpenTelemetry middleware that exists. We only wanted to make sure that we are invoking it, right? Not the we can remove that. Not that it does what it's supposed to do. But here we're doing our own. So let's start with this one. Bypass our friend, our enemy. Okay, so the interesting thing here is this is the same. When there's no deadline set, it uses the timeout anyway. We already know that. Like that's what our middleware already does. So I think right. It's really about this test. We could do something like this, and that would cover it. So deadline will not affect this request because it is unset. So I think that's adding an assertion there. I mean, this is kind of obvious. Like we spawned a new process. We didn't set the deadline. Yeah, it's going to be nil. But I think it's worth specifying that because we're going to do I think we should do 2 here. And there's a question in my mind about whether Small. Okay. So yeah, so we're configured for 100 millisecond timeout on this test client, right? So I think what we need to do is let's just do expect, and let's copy this one from up here, like so. But we're going to change it. It's not expect once. We're going to call it more than once. So I think 100 milliseconds. Let's say this sleeps for 75 milliseconds. Okay, and what we want to do is let me look really quick here. Okay, so if it sleeps for 75 milliseconds, we're not going to hit the timeout, right? So we should say assert okay, and we don't care, is test client get, right? Okay, so we're asserting that we don't hit the timeout there. But if we say deadline.set, say like 25 milliseconds, that's pretty small. Then we want to say assert error timeout, test client get, set a deadline that is smaller than the configured timeout. And then okay, so that should return a timeout, and then we say set a deadline that is larger than the configured timeout. And this one is the harder one. Now we could do something like expect. Does it have an expect n times? Okay, so we'll do expect. Let's do expect once. Right, so that's the first attempt. And then let's expect once again, right? And what I want to do here is set, let's do expect once, and let's do 120, right? So this will still give us the timeout from the normal configured timeout, but the deadline won't affect it. So let's set deadline of 200, and then we should get an error timeout, right? And then it's a question in my mind whether we need to do the bypass pass, but let's see if it fails first. Okay. Right. So we do one call. It sleeps 75 milliseconds, and then responds. So our normal timeout of 100 milliseconds shouldn't be exceeded. Normal timeout is used when deadline is not set, right? Oh, deadline is not set. Why did that? Okay. So let's just really quickly assert that there's no deadline set. It surprises me that there's no deadline clear. We can hack around it by using its process dictionary key, but I kind of would rather not do that. Okay, so if there's no deadline set, we make a call that takes 75 milliseconds, it should not exceed the 100 millisecond timeout. Okay, if we make that same call and still takes 75 milliseconds, but we have a deadline of 25, then we should get a timeout. And then if we have one that takes 120 milliseconds and the deadline is set to 200 milliseconds, we should still get the timeout because that configured timeout is smaller. Okay, let's run that test. Yeah, okay. And we got that again. So I think as long as if we get to this point, we need to do that again so that we don't get those weird shutdown errors. Okay, so now we have a potential problem. Uses the smaller of the set deadline or the configured timeout. Okay, on line 103. So on 103, we expected, okay, so let's make this smaller, honestly. 40 milliseconds. Try to avoid race conditions as much as possible. Okay, so that passes. And I want to make this one smaller as well, just to, well, no, that's fine. It needs to be longer than the deadline, right? This needs to be significantly smaller than the timeout. Okay, so now this question. We did some stuff up here talking about propagates the tracing context into the timeout, right? But that involves doing this with span and then asserting that we're getting messages back that are recorded spans. So we don't have that same sort of thing with deadline. But what we could do is, let's go ahead and make the propagation middleware. And then we can check, what am I trying to say? We can check about the state getting put into the child task via the propagation middleware. So we'll be checking it kind of from the outside. If anyone has any better way to test this, I think we I would take suggestions, but I'm thinking for right now, let's just make the deadline propagation middleware. Deadline propagation. Okay. And let's do something like this. Copy this stuff in so we have a place to start from. Okay. Propagates deadline information across the request to the server being called. Okay, and then right. So I think what we have some options here. Maybe we'll underscore them for now. Um, yeah, you could put it in the hotel baggage. That might be the thing is I've heard that the hotel baggage is more about building compatibility across different implementations of OpenTelemetry, and it's like it's implementation specific details. Um, because I've thought about doing that previously, and I think I had seen somewhere that they were suggesting um, that you put, for example, a deadline in the baggage, but I don't know what's recommended anymore. uh, let's see, and I, I don't know that we have any folks from the Erlang Hotel team on here. I don't think so. So, um, right. I think he says then you could propagate the deadline to any calls that are not Elixir endpoints. Right. I was just going to use a plain header. And you could choose how to interpret it. We can even let you set the header name. Um, so, so I think let's start with that. Um, and then in a future stream, if I'm wrong and you should use the hotel baggage, um, then we'll put it in the hotel baggage and we'll move on with our lives. Okay, so first we're gonna say we need a header name. Uh, we're gonna get from the options header name, and let's have it default to deadline. Okay, um, and then what's it complaining about here? Yeah, dialyzer, whatever. We'll get to you. So eventually we want to do tesla.run env next, right? So yeah, I agree, Chris. So he says, I'm sure the hotel context is definitely not the right answer, but that doesn't stop people from doing it anyway. This is true. Um, and but one thing about the deadline is like that would be useful to put in the baggage if you want that to show up on your spans, right? Because I believe the baggage would be added to spans that are active. But this is not primarily an observability concern. Um, so I think there's still value in having a separate header, even if we do add it to the hotel baggage. So anyway, okay. So we will have this option. You can specify the header name that you want. I'm using lowercase. You could make it uppercase or whatever, camel case, etc. But there's not really a reason to do that. We could also say something like time remaining or whatever. Yes, I know context does not necessarily need to be associated with spans. Um, okay, so we're gonna do, and this may actually need to be. If let's see, not in Rust. Don't type let, Sean. Okay, so we're gonna reassign so if deadline dot get no um, time remaining, we might want to match here instead, like we did in the other one. Infinity, we'll just return env. We don't want to change it. If it's anything else, what we want to do is Tesla dot put header this is env, the header name, and toString of value. And, you know, if we are evil, we could pipe this case to test the run. I don't think that there's any reason to do that. I'd like to be able to read this later. Okay, so yeah, that's really all we need to do. Now, here's a question. Should we add this to the defaults? And I'm feeling like maybe we should. Then if they adopt deadlines, they get it automatically. And they don't have to do anything new. But that would mean that we would have to have a default, probably that's empty. Yeah, let's go ahead and do that. So middleware deadline propagation, and we'll say module deadline. I'm gonna make a really long function name there, and then let's define that over here in our defaults module. Pull options should melt fuse options. Okay, we're gonna need a doc string for this. Deadline propagation ops. Really, it's just the header name, but this is a pattern. So there's a question in here whether I should, you know, maybe I should change this to fetch bang, right? And then have the default. Yeah, let's do it. Header is deadline. Okay, so default implementation of the options to hardhat.middleware.deadline propagation. That is included in the default middleware stack. Okay. These defaults include Z is being way too helpful here. Header. The name of the, and how do we format this above? Of the header added to the request. Deadline. I don't know what happened there. If anyone knows, tell me. Right. Okay. So then what we'll do is we'll go back in our builder, and just like we did these, we'll do a def delegate here, and then we'll make it overridable. And it was deadline propagation ops. To hardhat.defaults, right? And then 0. Okay. So so now we've included it by default, and we can go and test it. And then that's probably, I've gone way over my usual 2 hour, but that'll be a good place to stop when we have adequately tested this. Okay. And let's look at our timeout test and copy some of this goop. And we're not going to need that. At some point, maybe in the next stream, we'll make some case templates so that these tests don't have to be so full of extra stuff that's not relevant to the tests. That would be nice, and then we could co-locate the OpenTelemetry stuff in its own case template. Yeah, and then everything else will be like, hey, bypass open, start a pool, which is most of what we need. Okay, and this can be async true because there's nothing. Everything is be run in parallel. Let's copy this. Well, let's okay. We don't need the timeout middleware necessarily. But we might want another module actually with timeout. And then we can this is the way that we'll make sure that it's passed through, right? Let's get to that in a minute. I don't want to get ahead of myself. I think we should verify the basic functionality, and then we can worry about allowing somebody to enable it or disable it. And this is okay. Bypass. I don't think we'll need the pool in here, but let's pass it anyway. Okay. So we want to test deadline header, and we probably want to have another client as well. And actually, I forgot we need to. Let's forget the pool. We don't actually care about that. We want to make sure that all of these are started up, right? Test client with timeout. And then let's have another one, which is test client with options. Sorry, for a moment there I was thinking we might want to do something like put it in test client, but have it stuff something into the process dictionary. I don't know that that's really that useful. Deadline propagation options, opts, and then we'll say header foobar. Let's call it countdown. That's more fun than foobar. Okay, so is not added when there is no deadline set. Okay, and we'll say deadline header is added when there is a deadline set, right? and we want to, so deadline header is propagated through timeouts. So like this is actually not a great place to put this because it's really about the timeout middleware, but the only way we can test it is by having that information be propagated. So yeah, so let's say, okay, and then deadline header name is configurable. Okay. All right, so let's do this one. Shouldn't take too long. And let's do bypass.expect once. Bypass. And there are a couple ways we could do this. I'm kind of the mind that we should not have an assertion inside the bypass call. But if that is something, say, for example, I don't know if Mitch is still around. He does a lot of bypass. But if you've done this and you do assertions inside here, let me know. Otherwise, I think I'm just going to do con respond. Yeah, way to go. Con 200 hello world. Okay. What I want to do here is say parent self, and then we'll just send a message. Self. Not self. Send parent. Plug.con.get request header con and deadline. Right. So what does this do? Okay, so return a list of binaries. If there's nothing there, I'm guessing you gotta return an empty list. Okay, so what we're gonna do here is there's no deadline set. So let's assert that. Right? And then we're going to say, okay, we're going to make sure that bypass port. Okay, so that should work. And then we're going to say assert receive deadline empty list 500 milliseconds. Right, so essentially we're saying there's no deadline set, so there should be no deadline header sent in the request. So when the mock server gets the request, there should be no deadline header. Okay. Let's see if that test works. Oh, poo. This is what I get for... I'm still... It's been weeks and weeks. I'm still trying to get the Emacs key combos out of my fingers. Okay. And that one passes. We see we have a bunch of not implemented. Okay, so we're good that if there's no deadline set, there's no functionality added there. Okay, so we kind of need to do something like this again. And let's just copy that entire block. And let's set a deadline. Okay. And here's the interesting thing. This might not be true, but we can try it. because there might be a, timing issue between when we make this call and like maybe our process gets slept by the scheduler. Anyway, we'll see if that becomes a problem. If it does, then what we can do is like pull out this, not match on 50, but pull that out, try to parse it as an integer and make sure it's less than or equal to the deadline we set. Yeah, see, even I knew it would happen. Even in this test, it says, oh, it's 46. What were we doing for 4 milliseconds? Come on. Okay, so what we're going to say is this is the deadline. And then integer, parse. Okay, so we can say assert is there a string to integer? To integer. Yeah, I'd rather have the one that raises an exception. Yeah. So string to integer of deadline less than or equal to 50. Like that's the sort of thing we want to do. Okay. Let's run that test. Okay, so we have 2 passing. We are cooking now. Let's go ahead and copy pasta this again, and we will modify this. So what we want is we want to use the client with timeout, right? So we just change this to test client with timeout. And since our deadline is smaller than the timeout, that's the one that should be used. And we're not sleeping at all here. We don't need to test that. We already tested that if you set a deadline smaller than the timeout, it will, and the request will timeout. Then the deadline will be the one that is used. So we don't need to do that. What we are just checking is that because this middleware comes after anything the user inserts, that we want that deadline to make sure that in the case of a timeout, it gets inside the task that is spawned to implement the timeout. Okay. That was pretty straightforward. Let's test. Okay, so actually we got a timeout. That's interesting. Let's set it a little bit bigger. Honestly, I'm surprised. What was it doing for 100 milliseconds or 50 milliseconds? That's one we maybe need to watch. So I'm going to put a note here that says, depending on the host timing, this may fail. Look for a better solution. There's some questions about, does it take longer than 50 milliseconds to open a TCP socket and make a connection to the local host? Might be too tight of a deadline. Okay, and so this one is, this last test, is really just about propagation. Right. So it's basically like this. But what we need to do is, yeah, let's just copy deadline headers added when there's a deadline set. Right. This is not about timeouts or any of that. So we don't need to worry about timing. But what we need to do is say this is, it's using countdown as the header name. With options, right? Okay. So let's see if that test passes. Boom. Okay. I didn't start it. Clearly. Let's go up to, yeah. So we need to make sure that that connection pool is started. Okay. So deadline adder. Did I change the wrong test? Line 53. Oh, did I mess that up? Yeah, this one was not intended to be changed. There should be no timeout on that. And then the propagation one is the one where we actually want to have the timeout middleware in there. Okay, so those are all testing. Let's make sure everything else is testing. Nope. Okay, did I just like straight up copy that? Yes, I did. Okay, let's rename this module. Deadline propagation test. Okay. I don't know why that happened. Okay. So, you know, I had this to do down here, this note. I think what we need to do here is we don't want the timeout to trigger. And so what I'm going to do is I'm going to set this timeout really big. It needs to be smaller than the configured timeout, but right. So there should be no way that we hit even half a second on this test. Okay, let's run the test suite one more time. And we have a lot to add. Whew. Okay, so let's look at the diff. Okay, so there's our defaults and adding it to the builder. And then we change the timeout middleware to add deadlines. We added the deadline library and it's added to our mix lock. Remove just a comment from that test. Then we're, you know, just making sure that deadlines are not affecting the configured timeout. And then we're testing the integration on the timeout middleware. Okay, so let's add the updated files and lib and test. Look one more time. Okay. Right. Okay. Yep. Okay, remove that comment that nowhere applied. Yep. Okay. So add support for deadline with propagation. Okay, cool. That's a good place to end the stream. I'm sorry we didn't get to retries. but we can do that next time. The only thing that I think I should mention is I'm not going to have one next week. But since so that'll be the 27th of August, I'm not going to have a stream. But that might mean that since the following weekend is going to be a holiday weekend in the U.S., I might do an extra long stream or do 2 days in a row. So watch for that. And we'll try to get to retries, and maybe even we'll revisit Fuse and look at Regulator as an option instead of Fuse, or maybe make it configurable or something. And at that point, when we've got all of those pieces in there, I think we'll be at the point where we can start doing polish. We can fill out the README with a lot more details about, how to use this thing. We should probably, since we've been adding features, we should probably push to hex, even though this is like 0.1.0 alpha 1 or something. Alpha 0 actually. We can probably start to look at changing that version number and pushing things to hex. I do want to get this to the point where people are using it and they're submitting issues and pull requests. But for now, this has just been a fun adventure so far, coding this live with you all. And thank you for coming, heckling me, hanging out. And Chris, let's find some time. I do want to learn about how we might be able to put filibuster into this and let people take advantage of that, because that feels like something that would be super next level. So cool. All right. Thank you, everybody. I'm going to call it now, and I'll see you on the next one. I'll be on the chat for a little bit longer if you have any last-minute questions. Thank you so much. See you next time.